Good morning all. This is the project that I did for my thesis work, evaluation of two enzyme agarose gels on complex substrates. And it starts from a case study in which a painting on canvas had on the back side a so-called beverone. Beverone is a mixture of rabbit skin glue, linseed oil and colophony. It was used by painter conservator in past centuries, and in particular between 18th and 19th centuries. And we decided to remove it using an agar gel loaded with benzyl alcohol. But we decided to test another kind of gel, a greener gel, and in particular, we decided to test two different enzyme gels. So we started the experimentation with three different aims. The first one was to create gels easy to use, low cost as much as possible, but also effective. The second aim was to evaluate these two gels and to evaluate three different parameters for each gels: agarose concentration, method of application, and time of application. So we choose a trypsin and a lipase, and we will see how. Dispersed in a bile acid soap solution created by deoxycholic acid and triethanolamine, and gelled with agarose, following the three parameters that we have seen. Each gel was tested on different substrates formed by rabbit skin glue, linseed oil, and colophony, taken one by one in binary mixtures and a ternary mixture. The third aim is the evaluation method. The evaluation method is based on a measure of percentage weight loss after gels application and on elaboration of FTIR spectral analysis. We have also used a gas chromatography with high resolution, but we haven't finished yet, and so this part of experimentation is work in progress. Clearly, we tested enzymes gels on specific materials. Trypsin hydrolyzed proteinaceous material, and so we tested trypsin gels on substrate with rabbit skin glue. Alike, we used the lipase gel on model samples with linseed oil. The number of model samples is very high. For each kind of substrate, we have tested 8 gels due to the combination of three parameters, as we can see in the table. And it's also clear that where we find the rabbit skin glue and the linseed oil at the same time, we have the double the gels, both trypsin gels and lipase gels. And this is a picture that show the number of model samples. Well, now we analyze materials that forms gels. As we said, the aqueous solution is a bile acid soap solution. It's a surfactant solution made by deoxycholic acid deprotonized with triethanolamine. It's especially effective in removing terpenic resin like colophony due to its structural affinity. The gelling agent is agarose. It's one of the components of agar-agar, and it has a lower gelling temperature than agar-agar, 35 Celsius degrees more or less. This is really important in the creation of gel because enzymes are temperature sensitive, and a lower gelling temperature allows to add enzymes to the gel in safer condition for enzymes. And this is the particular agarose that we used, produced by Fisher Scientific. And now we are at the most critical part, the choice of enzymes. We read a lot of publication and papers, and for substrate with linseed oil, we decided to use lipase from Candida rugosa because it has already been used in combination with bile acid soap. It doesn't cost too much and it's easy to use because we can measure a great quantity without fear of losing too much powders. Instead, the choice of enzyme for rabbit skin glue was more difficult because we found a lot of different enzymes available in different papers. Our aim was to create an enzyme gel effective, easy to use and low cost, and so we have discarded all bacterial and fungal proteases and also collagenase for many reasons. Some enzymes are no longer available, some others are too expensive and small quantities are difficult to use during preparation process. And other enzymes have a low specific activity and so probably not very effective. We have found that trypsin from porcine and bovine pancreas are good trypsin, and the best compromise between specific activity, price, haste of use is this trypsin from porcine pancreas, and so we have chosen it. This is the cost and this is the concentration that we used. This slide resume enzymes characteristics. So for both trypsin and lipase, we have a range of pH from 7 to 9 for the optimum. The optimum for temperature is around 37 Celsius degree. Both are okay with bile acid soap solution, and the bond hydrolyzed is a peptide bond for trypsin and a ester bond for lipase. This slide shows the condition of gel's application. The set was kept at 37 Celsius degrees thanks to an air ceramic lamp linked to a thermostat. 37 degrees is the optimum for both enzymes, as we have seen. Solution is buffered at 8.5 pH point. Enzymes are added during cooling phase for both application method and gently mixed. In the first case, the fluid application, they are applied on the substrates by polyethylene pipette at 40 degrees, just before the gelification temperature. And gels are covered by a Melinex sheet during all application time in order to avoid evaporation and drying. So the gel preparation follows the same method for both enzymes. Aqueous solution is divided in two parts. In the first one, we put agarose powder. This part go under a heating and cooling process. Instead, enzyme is mixed with the second part and then added to the first part during a cooling phase, when temperature is safe at 42 Celsius degree, more or less. The difference between two enzymes is the volume of the second part in which enzyme is dispersed. It depends on concentration of enzyme. For trypsin, the second part is just 1 milliliter for 49 milliliters. For lipase is 15 milliliters for 35 milliliters. Well, this is the scheme of gel application, of the set for gel application, in which we can see ceramic lamp, thermostat, and model samples covered by gels. And this image represents the work set. Temperature was also controlled and verified by an air thermometer many times during all gels application, as we can see. All kinds of gel were applied 2 times. The first time was to calculate the weight loss percentage. For this purpose, after gel application, swollen material was removed from the sample surface using a cotton swab, in particular a cotton fioc. This double cotton swab was bound to a laboratory slide of the same type of what we used for model samples. It was scrolled 5 times with the right swab and 5 times with the left swab in order to remove all swollen materials. The percentage weight loss value was calculated from weight value before and after gel application, of course. Analyzing data, we can find that for whole substrate, gels applied fluid are more effective than performed gel, as we can see in our graphic. Furthermore, time of application affect the result. Indeed, gels applied for 30 minutes work better than 10 minutes application. And also gels with a minor agarose concentration are more effective than other, but this last one seems to be the less important variable. Then, in this graphic, we can compare gels of the same time. For example, fluid with 2% of agarose applied for 30 minutes. We can compare gels of the same time on different substrates. And analyzing them, we can say that they follow the same trend. And in particular, we can see the substrate with a compresence of rabbit skin glue and linseed oil on the right of the graphic. we find that in the first substrate, only glue and oil, trypsin gels have a better efficacy than lipase gels, while on the second substrate, glue, oil, and the colophony, lipase gels are better and more effective than trypsin gels. Then we realized another application of enzyme gels in order to verify the hydrolytic action of enzymes. And for this purpose, we applied gels. Then we collected swollen material and gels, and we submitted to a drying process known as freeze drying using this instrument, the Savant. And then we collected FTIR spectra of materials before and after gels application. We supposed to see some change between FTIR spectra before and after, and in particular some changes in peaks assigned to peptide bond and ester bond. And so for trypsin gels, we looked for a decrease of amide 1 peaks and an increase of carboxylate peaks. For lipase gels, we expected to see a decrease of carboxylic group peaks referred to ester bond, and an increase of carboxylic peaks from fatty acids. Well, in order to evaluate these changes, we have elaborated FTIR spectra. We operate a baseline correction and then had the convolution and peaks fitting in order to calculate the area of each peaks referred to hydrolytic action of enzymes. We have calculated the percentage values of peaks from spectra of materials before and after gel application. And we can say that for trypsin gels, we haven't found such a clear change, but we can see some changes in amide 1 peaks from before to after, and a little increase in carboxylate peaks. Maybe hydrolytic action of trypsin is more difficult to analyze with FTIR spectra, or maybe it needs an higher concentration of trypsin, an higher time of application. Instead, for lipase gels, we have found a clear changes in peaks referred to ester and to fatty acids. The first one decreased in all substrates, and the second one increased. And this confirmed the hydrolytic action of enzymes of lipase in this case. As I said, we have executed some tests with high resolution mass spectrometry with gas chromatography. It's the first time that this type of analytical instrument is used in Italy, but I can't say anymore because it's a work in progress and we have to analyze the first results. And so, conclusions. We have found and we have created 2 enzyme gels that are low cost, are effective and easy to use. We can say that on substrate with a compresence of rabbit skin glue and linseed oil, trypsin is better on glue and oil substrate 1:1 ratio, while lipase is better on glue, oil, colophony substrate 1:1 ratio. And in general, fluid gels are better than preformed gel. 30 minutes application is better than a 10 minutes, and less concentrated gel is better than a more concentrate. At the last, we have found a correct evaluation method that confirmed hydrolytic action of lipase and also trypsin. And that's all. Thanks for your attention.